In this lesson, we are covering a couple of important topics. Again, it feels like it's revision from last year, which is why if this was a year 10 course, I'd be spending probably 3 or 4 lessons on what we're about to cover in this lesson. So the pace is because it's supposed to be, how do I put it? It's supposed to be uh, uh, stuff that you've already covered, pre-knowledge they call it in IB language. So if the pace is a bit too quick because you personally haven't gone through it, you haven't done it before, then just know that you might need to do a bit more practice outside of school time to catch up if it's feeling like the pace is a bit too frenetic. Trust me, when it gets to more complex stuff or stuff that is, I know, grade 11 and 12 material, I will change the pace as we go along. So in today's lesson, this is something that you probably haven't done before, but the concepts behind it are pretty straightforward. It's something called a perpendicular bisector. Anyone heard of that? Cool. But you might have heard of those two individual words. So let's start off with the one that I'm confident that you would know. Who can tell me what perpendicular means? Eve? Yep, good. So you can see I've just sort of numbered them to make it easier. At right angles. Good to see everyone writing down theory notes. I didn't say to, but you're in grade 11 now, so I would expect that just to happen. Want to hear me? Now, here's the other word, bisector, which represents a line. So if we look at the first two syllables there, we've got bisect. Anyone know what bisect means, to bisect something? Sorry, Maddie? That's true. But specifically, it crosses through in a way that, Miles? Halves it. Yeah, good. Yeah, so the bi part of bisector means that you've cut it into two. So well done. Between the two of you, yeah, that's perfectly right. The fact that it's a bisector, though, makes it a line. So, for example, the classic perpendicular bisector is when you drop in an isosceles triangle, when you drop a line from the top vertex down at a perpendicular height to the base, it bisects the base line. Do you know what I mean? I'll write that, draw it down, but don't do it yourself. So isosceles triangle, if you remember, means that the two sides are equal and the third side isn't. And if you drop the height down, and by default the height must be perpendicular, so that bisects the baseline. That's a perpendicular bisector. The height, the line that is the height, is a perpendicular bisector. All good? Okay, so basically it means this. Oops, just going to change color just to make it stand out. Like so. Actually, you know what? I should actually make it a solid line. So that is the perpendicular bisector. The reason why I'm making it a solid line is that the between A and B, that's a distance. And I deliberately, I know it looks a bit vague. I said a line that cuts into two equal halves. That might not be very well written in a way, because it might be suggesting that it's the line that's cut into two equal halves. But the perpendicular bisector is the line that does the cutting. If that's not clear with what that state, I'm trying not to overword it. So that's my problem, is sometimes you need the words to make it clear. So the line cuts something into two equal halves, whether it's a baseline of a triangle, whether it's another line, or in this case, it's the distance between 2 points A and B. Okay, the perpendicular bisector cuts the distance between A and B into two equal halves. Okay, so we're going to do an example, and the example comes from the textbook. So I'll show you what that looks like. Back a few pages. So it's worked example 8 here. I just thought I might as well. So it says, given that A is 4, -3, and B, that is -2, find the equation of the perpendicular bisector AB. So I've started drawing it already, so I'm just going to put the points in, then I'll switch back over to the screen. So we've got 4, -3 from the question, and B is -2, Oops, got that around the wrong way on my drawing. So you can see from these 2 points, I'll just look at this drawing here, but then I'll go back. Find the equation of the perpendicular bisector. So you can see that it's 4, -3, and we've got B has gone to -2. So B is going to be before A, that's fine. And B is 7, whereas A is -3, which means it's going to be up 10 units, really, from -3. So it's back 2 and up 10. Okay, so that's that. And we need to find the perpendicular bisector. So there are the points in there. So if you remember, a straight line has the equation y equals mx plus c, where m is the gradient and c is the y-intercept. So if we need to write an equation that fits that format, we will need to work out the y-intercept and we'll need to work out the gradient. There are other forms available too. The textbook uses a form that I like least, which is the general form. So I'm going to do it via one of the other two forms. So importantly then, we need to work out the gradient to start with. And we don't have the gradient yet, so let's figure it out. So to figure out the gradient, we're going to use the gradient formula to work out the gradient of AB, because if we can work out the gradient of AB, then we can flip it to work out the gradient of the perpendicular bisector, right? I'll remind you of that as we go along. So step 1, we're going to work out the gradient. So M is equal to, again, you don't have to write the formula down. I will just for the completion of the notes, but it's the difference in Y over the difference in X. Rise over run. Sometimes you might see me write it like this, delta Y over delta X in short. So when you see the word or the letter delta, it often means change in for mathematics. So change in Y over change in X gives us the gradient. And we can see from our drawing, which we try to make as accurate as we can, sort of, we can see that it should be a negative number, right? Going downways from left to right. So let's put in our values and see how we go. So the Y values are -3 and 7. It doesn't matter which way you do this as long as you're consistent. So I'm going to use A as the 1s and B as the 2s. So I'm going to have 7 minus -3 all over -2 -4. You okay with that? That's equal to 10 over -6. Now, if we end up with a positive over a negative, then it means the result is a negative. So we can take that negative and make the fraction negative. If it was a negative over a positive, same thing. But if it was a negative over a negative, the result would be positive. So our usual division rules with negatives work. So that would be quite simply -5 over 3. Is that okay so far? Now I'm going to have to switch. Oh, maybe I'll just keep it. I'll keep gradient thinking along this line as well. Therefore, for the bisector, M is equal to 3/5. Is that okay? If you're a little bit more rules oriented, if you multiplied M1 times M2 and get -1, substitute -5/3 for M1, and solve for M2, you would get 3/5. For those of you that are happy to be a little bit more intuitive, all I've done is I've flipped the fraction here. 5/3 has gone to 3/5, and I've changed the operation. It was negative, so now it's positive. Great. So I said that we need the, yep. Oh, I'm going to say something which is a really bad thing for a mathematician to say. It just is, yeah. I can prove it to you, but ultimately the proof is that when you have perpendicular lines, their gradients, when multiplied together, give you -1. And there's reasoning, good, logical, hard reasoning behind it, but that's what it's like. So ultimately, that's what you do if you need to calculate it because you're not sure what you're doing. But ultimately, you take the gradient of 1 and you flip it and change its sign, and you get the gradient of the perpendicular. Yeah. I don't like mathemagic, but in this instance, I just want to move on. Okay, so generally speaking, when you're trying to work out the equation of the line, what you need is the gradient or some way of working out the gradient, and you need one other point. Once you've got that other point, you can substitute it into an equation form in order to work out the actual linear equation, right? So we need one other point. Now, it's a perpendicular bisector. Sorry, I put the emphasis on the wrong thing then. It's a perpendicular bisector. We've just used the perpendicular fact. Now we're going to use the bisector fact. So if it cuts it in half, we need to find this point here, the middle point, or if I get rid of the dull, that's actually what it's called. So if we find out the midpoint here, we're good to go. Again, I promise I'm not going to put you on the spot, just looking for what your knowledge is like. Who can remember how to find the midpoint between two other points? Okay. Good news is, in your formula sheet, formula booklet, under pre-knowledge, right? So it's kind of expected that you know this already, but I'm about to go through it. Under pre-knowledge, it has the formula. However, because you're all clever students, I can just say to you intuitively, it's going to make sense, the midpoint formula. It's basically the average of the x coordinates and the average of the y coordinates, if that kind of makes sense. Yep. So I'm going to have to flick between screens to go on to the next screen for this, so just bear with me. So we've got the midpoint of AB is equal to, it's a pair, so I'm putting in brackets, the average of the x coordinates, that's -2 plus 4 over 2. -2 plus 4 over 2. That's the x coordinate. And the y coordinates are 7 and -3. So it'll be 7 plus -3, or 7 minus 3 over 2. -2 plus 4 is +2. Divided by 2 is 1. And 7 minus 3 is 4 over 2 is 2. So the midpoint is 1, 2. I'll let that sit there for a moment. You can ask me questions. So it's not too bad, is it? I mean, sometimes, of course, you'll have fractions, but you get that. Kind of makes sense, I think. Halfway between 4 and -2 is going to be here. So back a bit. That's at point 1. Between -3 and 7, it certainly should be up here somewhere. It should be positive as well. So it kind of makes sense in the context. This just confirms exactly what it is. So now we've got the midpoint, we've got the gradient. Now we can go ahead and do it. Now, if you're not directly given the y-intercept, I suggest that you put it into point gradient form. So we can say, therefore, y minus and then the y coordinate, which is 2, is equal to, I think it was 3/5, wasn't it? Yeah. Is equal to 3/5 outside of x minus 1. Okay, so this is y minus y1 equals m outside of x minus x1. So we take we've got a point, we've got a gradient, and we're good to go. Now, I think technically speaking, you could leave it like that because that's in a recognized form. It's in point gradient form. But I think I'd personally feel more comfortable expanding it and putting it into y equals mx plus c. It doesn't take very long, and it's often a much more universally accepted form for the equation. So I'll expand it nice and easy. That's 3/5 x minus 3/5. And then I'm going to add 2 to both sides. Well, 2 is 10/5, right? So I've got minus 3/5 here. And I'm going to add 10/5 because I'm doing the reverse of this. Add 10/5. So minus 3/5 plus 10/5 is 10 minus 3. So it's going to be 7/5. And that is the equation in y equals mx plus c form. And it's the equation of the perpendicular bisector. Is that all right? Cool. Okay, so, no, I wasn't talking to you, Siri. What I'm going to get you to do from your textbook for the next 10 minutes is I'm going to get you to do exercise 1C. Oops, now do exercise 1C and just 2 questions from it. Question 1 will get you stuck into it. I've got 3 down really, but see how you go. 4, and then if you've got time, do question 8. Question 1, 4, and 8, see how far you go. Question 4 is not tricky, but it'll test some extra knowledge, I think. So if you get through to the end of question 4, that would be good.